Let's see if we can add some mixed numbers. Here we have a problem. Anna bought 3.5 pounds of ham and 2 2/3 pounds of cheese to make sandwiches. What was the total weight of her items? So we want to know if we add 3.5 and 2 2/3, what will we get? So what we're going to do is I have 3.5 plus 2 2/3. Now, in order to add mixed numbers, it's important that we understand what a mixed number is. A mixed number is the sum of a whole number and a fraction. So when I have a number like 3.5, it's really 3 plus another half. And 2 2/3 is like 2 plus another 2/3. So I can rewrite, because of the commutative property, I can rewrite all of this addition since I want to add all of these numbers. So I want to add 3 plus a half plus 2 plus 2/3. And if I rearrange these, I can see that I can add 3 plus 2 plus a half plus 2/3. I haven't changed anything except for the order. And that is the theory that I'm going to use to add these mixed numbers. So I can think of finding the sum of 3 plus 2, and then finding the sum of a half plus 2/3, and then adding those two sums together. And that's what I'm going to do. So first, I'm going to draw a line down here so that it looks like I'm adding the whole numbers on one side and adding the fractions on the other, which indeed I'm doing. So 3 plus 2, well, that's pretty easy. That's 5. And now I have to add my fractions. Now, this is just like any other fraction problem. I have to find a common denominator. So let me change the color just so we can do this. And if I look, I have 2 and 3. I want to find the least common multiple. I have 2, 4, 6, and I have 3, 6. So I am going to change this into sixths. Okay, so 2 times what is going to give me 6? 2 times 3. So I have to multiply this by 3, and I get 3 sixths. And down here, 3 times 2 is 6, and 2 times 2 is 4. So I'm going to be adding 3 sixths plus 4 sixths, and I get 7 sixths. Well, guess what? 7 sixths is a mixed number. And so if I use any of my techniques to change fractions to mixed numbers, I can look at this as 7 sixths equals 6 sixths, which is 1 whole, plus 1 sixth. Or I can divide 7 divided by 6, and I get 1 and 1 sixth. Okay, so this becomes 1 and 1 sixth. And again, if we think about the meaning of a mixed number, this is 1 plus 1 sixth. So what do I have here? I end up with 5 plus the 1 plus the 1 sixth, and that equals 6 and 1 sixth. So the total amount of her purchase is 6 and 1 sixth. Now, That sounds like a lot, but that's because I wanted to explain the theory of why we do what we do. So let's take a look at another problem. And let's take a look at a problem without context. Okay, so what if I add 4 and 2/5 plus 5 and 2/3? Okay, I'm going to do what I did above, but without all the explanations. I'm just going to do the mechanics. So, dividing this, I know that 4 plus 5 is 9. And let me set up. Okay, so 5, 10, 15, 3, 6, 9, 12, 15. So 15 is going to be my least common denominator. Okay. 5 times 3 is 15, and 2 times 3 is 6. 3 times 5 is 15. 2 times 5 is 10. And so when I add the fraction portion of this problem, I'm adding 6/15 plus 10/15, and I get 16/15. That equals 15/15, which is 1 whole, plus 1/15. Okay, so I am going to add 9 plus 1 plus 1/15, and that is going to give me 10 and 1/15 as my sum. And that's the way that we add fractions. You may see another method, which is to change both mixed numbers into improper fractions, and then you can add them as fractions. I prefer not to do that because you end up with some pretty big numerators sometimes, and I like to work with smaller numbers. So this is the way that I add my mixed numbers.